Welcome, everybody. Thanks so much for attending our webinar on converting SPARC optical microscopy imaging data and metadata with MicroFile Plus. We're excited to show you how to use our brand new desktop application, MicroFile Plus, to convert microscopy data with the additional metadata to promote data interpretation and reusability. For those of you who don't know us, I'm Macy Heel.
And I'm Aidan Sullivan, and we're part of the SPARC team here at MBF Bioscience. SPARC is an NIH Common Fund program that aims to accelerate the development of therapeutic devices that modulate electrical activity in nerves to improve organ function. The experimental data generated in the SPARC program is highly curated to ensure data published to the SPARC Open Data Portal is findable, accessible, reusable, and interoperable, or FAIR. The tools available on the SPARC portal include source data, dynamic organ maps, and computational models and simulations, encouraging seamless reuse and driving scientific discovery, specifically to identify and influence therapeutic targets. Thanks everyone for attending our webinar. A quick note for those of you who are here and hear mention of SPARC but are not part of the SPARC project. You may be questioning, why are you here? What webinar did you sign up for? What day is it? Please know that the utility and accessibility of MicroFile Plus is not limited to SPARC researchers, though this presentation will discuss a SPARC-specific application of the product. MicroFile Plus is a free product available to help drive fair microscopy image data from your experimental data sets, whether you're part of SPARC or not. Please stay tuned as we demonstrate how to use MicroFile Plus and how to download the application.
We'll leave the last few minutes to answer your questions, but please feel free to ask questions throughout the webinar. You can submit a question by simply clicking on the orange arrow button on the GoToWebinar control panel. Find the question panel, type the question in the box, and click send. If desired, you can undock the question box from the panel for a better view of the questions and answers. Here's a little infographic of how to do that on the screen now. Also on the line today with us is MBF Bioscience's Scientific Director, Dr. Susan Tappan, and also the Product Manager for MicroFile Plus, Dr. Nathan O'Connor. We'll all be available to answer questions at the end of the webinar. Any questions we don't get to, we'll be sure to follow up, so please submit them.
MicroFile Plus is a novel, freely available file converter. It ingests proprietary image file formats and converts them to more widely supported image formats inclusive of important experimental metadata. Metadata is a set of data that describes and gives information about other data. This information is contained in the area of the file called the file header that can be easily accessed and read by humans and computers. The image formats OME TIFF and JPEG 2000 were selected because of their readable metadata storage, compatibility with open source software such as ImageDay and Fiji, longevity expected for file format support, and web streaming capabilities. Microscopy imaging data is a common experimental modality and is inherently diverse. Variability in experimental sample preparation, as well as microscopy settings, methods, and equipment all contribute to the complexity. By providing a form of the source image data in SPARC datasets as two open formats inclusive of essential metadata, we aim to reduce the barrier for using this image data.
MicroFile Plus can be used to drive the reusability and understanding of your data with rich metadata. The addition of experimental metadata into your datasets will increase the value of the data and allow for a deep understanding at a file level. By applying a consistent set of imaging-specific metadata for imaging data across the SPARC ecosystem, the image metadata can also be harnessed to enhance the functionality of the SPARC data portal. It can assist with automated quality control checks during the data curation process, and it can be further leveraged to enhance SPARC Portal search queries and increase the findability of your datasets by capturing elements of microscopy that may otherwise be overlooked.
I agree, Macy. Oftentimes when curating SPARC microscopy image data, I find that there are target labels missing from the metadata of multi-channel microscopy images, like the one you see on the screen. If we could add this information to the metadata, it would help others seamlessly interpret the sample in context of the experiment.
Exactly, Aiden. MicroFile Plus will allow you to visualize the metadata that is already contained in your microscopy images, but it informs you of what essential metadata is missing and allows you to add it to the file. The original metadata is preserved, but when the required metadata option is enabled in the application, which Aiden you'll demonstrate later, we can use MicroFile Plus as a tool to check that enough information is contained in your data to allow others to interpret it. Some of the required metadata fields include the channel target label, the fluorophore, and the color of each channel in a multi-channel image. Without knowing each histological label or stain captured in each channel of the image, it's simply not possible to understand the content of the image fully. Equally as important for repurposing and analyzing image data is the X and Y scaling, as well as the Z spacing for three-dimensional image data. By knowing the actual dimension of each pixel, accurate measurements can be made, allowing for alternative image analysis or reproduction of derived morphometric conclusions. When converting with MicroFile Plus, the software's Research Resource Identifier, or RRID, is automatically added to the file metadata to ensure the data generated is reproducible, reusable, and citable. The RRID is a unique identifier that's registered in the SciCrunch knowledge database. All metadata is written directly to the converted image formats. These are OME TIFF and JPEG 2000, and will never get separated from the image data because it's all saved at the file level, unlike a sidecar metadata file.
So how do you use MicroFile Plus to convert microscopy image data and add or amend associated metadata? I'll demonstrate the conversion workflow, including metadata updates. When you launch MicroFile Plus, the first step is setting up your conversion. For today's demonstration, we will simply convert independent images to JPEG 2000 and OME TIFF formats. However, MicroFile Plus is capable of combining 2D images into 3D stacks. It can also be used to combine single-channel images into multi-channel image or stack. And lastly, it can be converted into a min, max, or deep focus projection. To convert either 2D or 3D images into JPEG 2000 and OME TIFF, select Convert Images. Next, choose the output file format. You can either select JPEG 2000, OME TIFF, or both. Following this, you will choose your JPEG 2000 compression level. Optimal compression levels will be image dependent and should be set to the highest compression level possible without introducing artifacts to improve web streaming speeds. We recommend a compression ratio between 20 and 40 to 1. The OME TIFF will always be a lossless conversion, meaning no compression is applied. In the advanced settings, make sure required metadata entry before saving is checked. This setting will highlight missing metadata fields that are necessary for generating fair image data and repurposing the image file. When you've finished configuring your settings, simply click Next. To open your images in the program, simply drag and drop into the window. You will see the original file formats. Today I have a CZI, ND2, and TIFF file format. And then you will also see at the end of each format, there is either a green check or a red X. The red X indicates that required metadata has not been entered for this TIFF image. To add and modify this metadata, simply select the image that you would like to edit and click Show Metadata. Required metadata fields will be highlighted in yellow. And required metadata fields that are missing will have a red highlight. For this TIFF, you can see that X, Y, and Z scaling are missing from the image. So to add these, I'll simply click and start inputting the values. you see that as I enter the values, the red highlight is removed. And over here, the red X changes from an X to a check, indicating that all required metadata has been inputted into the file. Now that I'm reviewing this metadata, I see that the target labels are incorrect. So I'm going to input the appropriate values by copying, pasting them into MicroFile Plus.
Hey, Aiden, this seems like it could be a lot of work if my dataset has thousands of images that are missing required metadata, like the image scaling or the target labels, as you're doing right now. Is there a way to fill in that information across a set of images that all need the same set of information?
Yes. Working closely with many submitted SPARC datasets, we have already curated a large variety of microscopy data. Some datasets include one image, and some have over 30,000. Keeping this in mind, we designed MicroFile Plus to enrich image metadata with ease. Check out this feature, Macy. Here, we have experimental presets. So you can create an experimental preset for images that follow the same experimental protocol. It's likely that images like this will have the same metadata values, such as target label. By setting up the experimental preset once, you can then apply all of these metadata additions or changes to the whole group of images. Let's take a closer look at the experimental presets that I've already set up here. You can see that I have called the experimental preset with the subject ID, and this indicates that all images of this subject have the same metadata, image metadata. Each sample image has the same modality, laser scan and confocal microscopy, and the same target labels. You can also add information about objective and camera and save that to your experiment. When you're finished with generating your experimental configuration, just click Save. And now I'm going to select my CZI image that this metadata applies to, and you'll see that the target labels for this image have already been input, but they're not descriptive. So instead of checking, so I would like to uncheck Apply to Missing Fields Only, because I want to overwrite this already input metadata with what I've saved in my experimental presets. I'm going to click Apply to Current Image, and you'll see that I now have the modality and the correct target labels input into my image. Now, I just did this with one image, but you can use the Apply to All Image button here to change the metadata for every image that you've loaded into MicroFile Plus. This saves me so much time. Adding metadata is a breeze. Now, I want to show you that once you convert these images, the results fully reflect the source image data. I have opened each image file that I've converted in MicroFile Plus and the original in Neuralucida 360's 3D window. These images are courtesy of Dr. Martha Campbell-Thomas's lab. And on the left, I have my CZI, my original source image, and on the right, I have my OME TIFF. You can see that these images are exactly the same. Let's take a closer look at the metadata that's applied to each image. You can see that some values, like scaling here, are the same, but in my converted result, my OME TIFF, I have my channel labels and my modality written to the data file. So now I can start to put context into this image and really start to understand what's happening. Whereas in my original source image, I have channel labels that are not appropriate and are not descriptive of what's in the image data. You can see the same is true for the JPX version of the image. We have a comparison to the original CZI. Even with that compression applied, the images look the same. And what's different within them is those the metadata. So you can see that channel labels have been added using MicroFile Plus. So to convert these images, all you have to do is click the Convert button in MicroFile Plus, and your process is going to start automatically. You can see that there are 6 images here that are being processed. That reflects the OME, TIFF, and JPEG 2000 versions of the 3 images that I loaded into MicroFile Plus being converted. For efficiency, you can even have multiple copies of MicroFile Plus open to simultaneously convert multiple sets of images at once. So if these two source images are if these images are the same as the original source, then what's the point of converting them at all? Well, Macy's going to tell us more about the benefits of making these data types available on open data portals like the SPARC data portal.
Thanks, Aiden, for the demo. That was great. It looks like MicroFile Plus converts microscopy imaging data to more widely supported image formats while adding that consistent set of imaging-specific metadata. MicroFile Plus, again, can be used to drive the reusability and the understanding of your data with this rich metadata. Here on the screen are a list of the current supported file formats that MicroFile Plus allows to ingest. You'll see it supports a wide selection of image formats from a variety of different hardware vendors, microscopes like Nikon, Zeiss, Olympus. File format support is a continual process for us, and each of these file types can have edge cases or variances that will need to be supported later. If we do not currently support your file format, please contact us on the MicroFile Plus web forum. We'd love to hear from you. The addition of consistent and rich metadata increases the fairness of SPARC data and other data. Here we provide instructions on how you can view both OME TIFF and the JPEG 2000 file formats that are derived out of MicroFile Plus and see their image metadata as well using the ImageJ or Fiji Bioformats plugin. Please feel free to look back on these instructions once this webinar is posted on our YouTube page.
Remember, this software is free, and here are instructions on how to download and install MicroFile Plus. These instructions will again be available once the webinar is posted as an online resource, but you can visit MBF Bioscience's website today and download the program. Just click the download button and fill out the web form. We'll send your license code via email. For those of you working on the SPARC project, please indicate your association on the web form.
All right, that about wraps it up. Short and sweet webinar. Thank you all for listening to our presentation, attending today. We really are excited about the first release of this tool, and we hope that it will help drive the reusability and the understanding of your data with this rich metadata, especially for your microscopy image data. Here are a few resources for you to access. And please be sure to check out sparc.science. It's the SPARC Open Data Portal Hub. And there's a lot of wonderful, fair, and open data sets for you to peruse on there. So check it out.
It looks like we have a few minutes left to answer some of your questions. We also have Dr. Susan Tappan and Dr. Nate Oconnor on the line to provide their expert opinion. So we'll get started with any questions.
Please feel free to send them through the questions box on the bottom of the GoToWebinar screen. All right. Aiden, someone asked, does MBF Bioscience provide technical support for MicroFile Plus?
Oh, good question. Currently, MBF Bioscience does not offer a subscription-based technical support for MicroFile Plus. We do have resources like the web forum as well as the help guide. And those can be located on our website, and there are also links in this presentation to find them.
Thanks, Aiden. I apologize for my dogs. All right, let's see. All right, we have another one here. Is there a limit to the number of channels in the JPEG 2000 files? There is not. I'll take that one. There is not. We support multi-channel image data, and there can be a number of channels that can be put together. Stu, do you want to add more to that question?
Right now, we'll write up to 16 channels with JPEG 2000, but the file spec itself supports thousands, so it can handle as many channels as you're generating as part of your multi-dimensional image sets.
Great. Another one here for you, Sue. How do you determine the XYZ distance information if it's not available in the available metadata that populates when you open an image?
Yeah, and I think that particular question is why it's so important to record this information. The person who collects the image at the microscope itself should have an awareness of the scaling due to the optics that are used on the microscope at the time of acquisition. So the microscope itself often records the scaling information, so the microns per pixel sizing. But the other thing that we recommend is that you utilize your microscope's native software acquisition. So for example, using Zen when you're using a Zeiss scope, so that they will record the scaling for you. If the scaling is embedded, using MicroFile Plus will automatically pass that through. So if it's a 2D image, it will report and record the XY scaling. If it's a multi-plane 3D image, then the Z scaling will also be transferred. If you don't know, but you do have a micrometer from an older setup, we can help you through those processes of figuring out what the micron per pixel scaling is. And just post a question on the forum and we'll provide some explicit instructions.
Thanks, Sue. We have one here. Besides ImageJ, which other kinds of software can open the OME TIFF in the JPEG 2000 formats? Photoshop, I know, is one that people use. Any additional, Sue or Nate, that you can think of? MATLAB, Python, other applications?
I think Scan Image also supports OME TIFF, but there's a broad variety of image applications that can read that in, which was one of the reasons why we chose that as a format to create, is that it's open, the spec is available, it is accessible.
I just want to add there that all MBF Bioscience products can also open these two formats.
Yes, definitely. And as you demonstrated, you can see that metadata. We populate that metadata in the image organizer, so you can see that right away without having to dive into the file. But if you needed to, it's in the file in a readable way. So, okay. Let me see here. All right, Nate, is there a size limit to the files that can be converted, Dr. Oconnor?
Hey, everyone. I would say to that, no. And we regularly work with images from whole slide image scans that are in the hundreds of thousands by hundreds of thousands range by thousands of planes. So practically, we haven't tested that, but we haven't encountered a limit.
Great. All right. Someone else has asked, I have a Huron scanner. Can those files be converted? The answer is yes. They can be.
Yep.
And again, we have support for a lot of different file formats, and we will continually add support to those files. So please contact us.
There's a question also asking if there's a maximum number of files you can convert at once. You can create the queue with as many files as you want, and then specify how many versions of those files you create, either an OME TIFF version, a conversion, or to JPEG 2000, or both. So for each file that you have in the queue, you could create 1 or 2 images as an output. So there's no maximum. The queue is the queue. And I think we've found, Aidan, you mentioned that you can spawn multiple instances of the application. So if you've got files in a particular source folder that all have the same experimental categories or conditions, you can set up a preset for that, convert all of those guys, and then spawn another one and have a different set of preset and spawn or convert multiple images from that experiment until you have converted all of your data. Is that how you typically do it, Aidan?
Yeah, that's definitely how I do it, especially for SPARC data sets, which can have a variety of image types within one single data set. And so I will often need to set up those experimental presets for a few different cases for one data set. Yeah.
Someone asked if the webinar will be available offline, and yes, it will be. We'll be posting it on our YouTube channel, and you will see it on the SPARC data portal as well. Another question for maybe Dr. Oconnor or Dr. Tappan. The question is, can you tell me if it is better to, I'm sorry, what's the difference between TIFF as saved by Photoshop and OME TIFF?
Sue, what I'd say is OME TIFF really provides a standardized way that microscopists have agreed upon to save metadata within the file, whereas it's more of a, it's harder to specify that from Photoshop as you're saving TIFFs.
That's my understanding as well. It's the metadata. It's the part that you don't actually see that is the different structure. I'm not sure exactly what Photoshop utilizes for metadata fields when they are saving data, if they're using the entire structure that's available in the spec, but the OME TIFF does.
I often see that when you save as TIFF in Photoshop, you oftentimes lose the scaling if it is already embedded. So the OME TIFF will keep that information with the file itself.
I think that also, that same concept hits on this other question, which is MicroFile Plus converts image file types to other compatible formats while retaining metadata. But are there other advantages to using MicroFile for saving stacks? I only use ImageJ, so I do not need to take advantage of converting it to another software. I think that is an important consideration. So there is one thing about using the data that you've generated yourself, where the metadata that is present is something that you're also already you're already aware of what the labels are in that image and what the scaling is. And so if the image data actually has that information recorded, then that's great. What we've seen from curating thousands upon thousands of images is that those two components, what individual channel labels are and what the microns per pixel or the size of the voxels are both really important. And so when you use Fiji or ImageJ, you want to make sure that you have the ability to update that information so that the image travels with that important metadata from place to place and person to person. And so when you're creating your data to be open and more fair for others to use, I think it's really important to make sure that that metadata travels with the file. I'm not aware of Fiji being able to add or augment metadata within your file. So that may be a key distinction between the using MicroFile Plus or not.
In addition to that, it offers some of the same tools that Fiji and MSJ have for combining single channel images into a multi-channel image or 3D stack. And with that, like Sue said, that metadata is retained where maybe it's not, and it's editable in MicroFile Plus.
Thanks again to everyone who has attended, who's asked questions. We appreciate your time and attention.
All right, bye guys. Thanks for joining.